Hey everybody, this is TimeTravelBeard, and this is episode 7 of How to Make Minecraft Shaders. Today we're going to do normal maps, which is kind of 3D shading on textures. I'll go over some concepts. We already went over some of it earlier, so kind of just expand on what we learned before. Every block that we've got is like this. You know, we've got our little vertexes in the corners, and those connect to make triangles, and these triangles or faces are the 3D parts that we're rendering. We already, with our other shading when we did the different lighting modes, that's only when we passed the normals, which if you remember, that's an arrow that points the direction that the face is pointing. So the floor points up, the walls point sideways. And what we were doing is we were comparing that direction to where the sun is. We're having a bad time. If it's pointing towards the sun, it's more lit. If it's pointing away from the sun, it's dark. What we're going to do is we're going to load textures, normal map textures, that let us not just have shading per face, but per pixel. Let's open up the internet here, and let's just look up normal maps and see what comes up. And we'll get a little visualization. So here's some pictures, and you see that the way it works, the easiest way to imagine it is the blue is facing towards you, and then red and green, depending on which format it's using. And this one, green is pointing up, red is pointing to the right. So a lack of green is pointing down, and a lack of red is pointing in that other direction. And we can use this to do lighting. So if you imagine if the light was coming from up, then where it's green, you'd make it brighter. If the light is coming from the right, then where it's red, you'd make it brighter. So what we're going to do is we're going to load in the normal textures, and then we're going to transfer data around in Minecraft to make it work. And how we're going to do that is we already have this normal, but if we're going to translate it to say a texture, like let's say here's our texture, and green is pointing up, let's say, and let's say that red is pointing to the right. For us to make that work in this space, we're going to have to move this onto here. So we're going to take these corners and kind of like align them. You remember that when we did space transformations, we were moving vertexes? What we're doing here is we're pretty much moving this texture onto here. And we're going to make it so that this red arrow points perpendicular to the blue arrow. And we're going to make it so that this green arrow that's going that way on the texture goes like this. That way is if we've got a circle here that's green on the top, and we put that texture down here, we would say that the texture is then pointing in this direction. And these all have 90-degree angles. But that's what we're doing is we're going to translate that texture's coordinates saying which way something is pointing onto the face. And then we're going to take these new calculations we have. Because if you take these three things together, it gives us a new normal for that pixel. So like if this pixel is green, then it's pointing the normal in this direction. If it's half green and half red, it's pointing like this. If it's half green, half red, and also pointing towards us, then it's going up like this. So that's the concepts. And now we've got to just get into actually doing it. So the first thing we need to do is we need to have some actual textures that have normal maps. What we're going to do is we're going to just use Patrix because there's a free version. It's easy to find. And I use it for a lot of things, so I'm just familiar with it. So I'm going to just download this. And then we've got that now. And if you don't know how to do resource packs, you're just going to copy this and paste it inside your resource pack folder. I guess we can go ahead and do that. We'll copy this, close this, need to open Minecraft back up. You go to installations, and we've got our one to work on. We'll go to this folder, and then inside of our main Minecraft directory, should be something called resource packs. We go in there and we'll just paste it in here. And then now we've got that here. So let's start Minecraft. While that's starting, we're going to go into our Notepad. And again, we're going to do file close all to get to a blank slate. And then let's go to open, and we're going to go into shader packs, tutorial 6. Copy paste. My brain is not doing well. I'm doing this the same day that I just did that last one, just to kind of knock it out since that one was fast. This will be a tutorial 7. And let's find where that is now. Go in here, shaders, and we're going to start in our main vertex shader. And we need some new information. First, let's look at what we were already doing with our normal maps. We had the normals of the face we were already passing forward. And what we were doing is we were normalizing the normal we get from OpenGL times this matrix to put it into that view space. We want to also pass a tangent. So we're going to copy this varying, and we're going to make another thing here. Instead of normal's face, we're going to say tangent. The tangent is that line that's going like either up or down on the red or the green. It's one of those. And we're going to do very similar to what we're doing with this. So let's copy this line. And we do this here. But instead of using GL normal, we need to use something we're getting from Minecraft. I actually just copied it here for reference so I could do this quick. You can find all this stuff like usual if you are just in like the Iris docs. Let's see if this comes up first on Google. It still doesn't. Here we go. You could type this in here. So we're looking for our tangent, and we've got AT tangent, which is in vec4 tangent. So we can copy that. I don't know why it doesn't want to let me. And then back in here, we can just paste that we want that as an attribute we're taking in. And we're going to take this AT tangent, and we're going to use that in place of GL normal, because we don't want the way the face is going, we want the way that tangent is going. And that's not going to be our normal face, that's going to be our tangent for the face. I think that's all we need to do here. Let's save this, and let's go to our fragment shader, and we're going to make a visualizer so that we can see our normals since we're working with them. So what we'll do is we'll make a debug view. Let's say if debug view is equal to 1, we're going to do something different. And what we're going to do is we're going to visualize the normal. So let's take color.rgb, which is our main output color, and we're going to have it equal our normals. Because let's see what they look like. We know what they look like online. Let's see what the Minecraft ones look like. So normal's face dot xyz. So we want to know about this stuff. We don't want to just do the code. We want to understand what's going on. So let's take our debug view and make this actually be a thing. Let's go into our settings. We'll define it. And we're going to end up playing with this a lot, so we'll keep it towards the bottom of the thing. 0 and 1. And let's put this down. Save this, and we need to put it somewhere in our shader.properties. We'll put it on our main screen here, just on the bottom. Okay, let's go into our world. And we need to load our new shader since we're working on a new one. So this is a tutorial 7. Let's apply it. And we've got an error somewhere. We didn't change much, so let's see what we might have messed up. Actually, let's do the smart thing. Let's look at our error. Let's copy the error. Let's do file new, paste. I don't know what that means. So there's an error somewhere though. Let's look at what we've changed. We'll comment this out in the fragment shader just to make sure it's not that. Let's go in here and we'll comment out the things we did here. Again, debugging is good practice. And we added this here. So let's hide everything we did new and make sure that this works. Okay, it does. And let's add things back one at a time. That's a good way to debug. So if we add that back, does it work? It does. So let's go to the next thing we did, which is that we added a varying called tangent face that we're going to pass forward from the vertex shader to the fragment shader. I don't think that could break. Maybe we missed something. Okay, that's good. And then what did we do with that? We said it is a normalization of this times that tangent. Oh, that's our problem. That tangent here is a vec4. We're going to take the x, y, z of it. We only need the 3 values. And I believe that fourth value might actually have a purpose. So we're going to do something with it here, which is we're going to take this and we're going to multiply it by the tangent.w. You either are supposed to do it times tangent.w or times sine tangent.w, and that just kind of flips which direction it's pointing, which I believe is for like when the textures kind of flip. Let's see if that works. Let's just step through this and see what's giving us a problem. Again, debugging is just stepping through things one step at a time. Okay, so it's got a problem with tangent.w because that's not a real thing. We need to take a t-tangent.w and do that. Let's see if that works. It does. Cool. So we just had some debugging practice and we got better at debugging. If you pay more attention the first time through, you don't have to mess things up as much. But also you should very continuously refresh and check your code. So you don't get too far in and have to check too many things. Let's go to our fragment shader and see if our debug view works before we do anything else. Let's reload. Go to our shader options, put our debug view to 1. And what is this? This is cool. So it looks like green is pointing up and red is pointing to the right. Which is kind of fun, which kind of makes sense because the X is our left and right, and it's X, Y, Z, red, green, blue. So red would be X, green would be the Y. And you can see that if we move the camera, it changes because this is in our kind of the space of our view. This isn't how they're pointing in the world. It's how they're pointing relative to our camera. But to make this look like normals that we saw somewhere else and to show us more of what's going on, we're going to do times 0.5 plus 0.5. And I'm going to draw you why this works. The colors we get that we're showing on the screen are between 0 and 1. But a normal can point in both directions. It can go this way or that way. So it can be from -1 to 1, with this being 0. And this is a range of 2. So if we want to show -1 to 1 in a 0 to 1 color range, we need to do half this, which would be the times 0.5. And then if we half it, then we've got -half to half. So we're going to shift it half this way, that then this is, it fits right here, if that makes sense to you. So let's save this and let's refresh. There, and that looks more like the pictures. The blue, like the pale blue, is pointing towards us, green is pointing up, and red is pointing to the right. And if we look at things that are pointing not to the right and not up, they're darker of that shade. That's just a fun little visualization for us. Now, if we want to actually have these pixels or these normals per face, let's see. We need to load in that texture data and then do these transformations to it. So let's look back at what we had here in our vertex. We were sending this forward as varying vec3 tangent face, just like our normal face. So let's go into our main here, go to the top, look for varyings. Here's where our normal face is. We'll put it right next to that. And then let's look at what we're doing with our normal face. Using it in lighting style 2. So we'll make sure that we're in lighting style 2 so that we actually use this data when we're checking this. Let's go ahead and do that. turn off our debug view. Go to lighting style 2. Okay, and here's just this texture pack just here. We don't have it on. Let's put it on. Patrix 32x, basic. And we've got textures. In this pack, some easy ones that are good for seeing texture. Let's load up cobblestone, and let's load up a chiseled block. And we'll just put these down somewhere. And then we'll look at them to see if our shading's wrong. It doesn't look like there's any kind of directional shading yet. Like that looks like it's pretty flatly shaded. But then it's darker on just per face. So let's get in here and we need to do some stuff. We talked about doing that transformation. So what we're going to do is we're going to give math to turn this into this. So we want to take these directions and do them here. So we're going to take these colors that we had on the screen in our debug view, which was which way the face was going. We're going to do that same thing where we transformed just the normal coming off the face. We're also going to transform this, and we're going to get this one, the red one, with a math formula that gives us that. And then we're going to multiply these by those through like a matrix to just move that over as a space conversion. I copied it over in a spot for me in case I did it wrong. And since my brain isn't doing that well, we're going to just, I'm going to copy paste these over there and type them again, just so I do it right and don't waste your time. And we're going to do it before we do our light dot calculation because that compares the normals to the thing that's casting shadows. So what we need to do is we need to construct what's called a TBN matrix. And to do that, we need our normals that are from the face, our tangent, and a bitangent. We'll name this correctly. And the bitangent is going to be another vec3. And what it's going to be, actually, I'll just comment these, and then I'm going to type them again and explain them. So the bitangent, we're going to do a vec3 called bitangent. And this is just going to be the cross product between the other two. In math, if we've got something pointing this way and something pointing this way, and we want something pointing that other way to make them all be 90 degrees, we can get that in OpenGL by using cross. So we'll see vec3 bitangent equals the cross product of the tangent that we're bringing in, which we transformed into view space, and we're going to take the x, y, z of that and the normals face that we already had, the x, y, z, and we already did a multiplication of the tangent w in the vertex shader. We don't need to worry about that. So our bitangent will be the cross product of those two, and that gives us our bitangent. And then we can make this transformation matrix to move that 3D texture into the screen space. And that's the reason it's called TBN matrix is because it's the tangent, bitangent, normal matrix. So let's make that. We're going to make a mat3, which is like a three-way matrix. We'll call this TBN matrix. And this is a mat3. And what it's multiplying by, we have to open and close these parentheses, is going to be our tangent xyz, our bitangent xyz, and our normal space xyz. And what that means is it's going to multiply those values by this so that if it's pointing to the green, it points towards one of these, turning to the blue is one, to the reds is another. That gives us our matrix. And I didn't put in how to actually use it, so we'll do that in a minute and experiment with it. But we also need to actually have those texture values loaded in. We've already been loading the red, green, and blue values as our texture. If we want to also load the normal texture, we need to put it here. And it's called normals, I think. So let's do this. And just to test that we're loading it right, let's go to our debug view and let's make a debug view 2. Just copy this and paste it. And we'll say that, let's look where we're loading our other texture. It was like this. We're going to load, instead of texture, we're going to load normals. So let's say color RGB equals texture 2D, texture text chord, but we want that to be normals. And this will load texture called normals at our text chord. And we're going to do that nice little math to make it fit on the screen right again. But we'll say this is debug view number 2. We'll save this. Let's go into our settings. Let's make sure this has a second option. Let's go back into Minecraft. Let's reload. So we have an error somewhere. So let's go back to here. Normals. Let's see if this is our problem. Oh, we did a few things here. Let's see. Let's just comment these things out one at a time, and then we'll just Control Z to undo, go back through them, and see what the problem was. So let's save. Let's reload. Okay, we're good. Let's undo this one with Control and Z. Save. Get back in here, refresh, and it's still good, so that's not our problem. Let's Control Z again to have our bitangent. Okay, that gives us a problem. We never put our varying tangent in here, it doesn't look like. It should be tangents face is what we used. So let's get back down here, and our tangent is the tangent of the face. Let's save that. Let's see if that now loads properly. It does. Let's have that actually be made. That's fine. So let's go down at the bottom here where we have our debug view. And let's see if that works. It doesn't have a problem with the code, but the code isn't activated. So let's go to debug view 2, apply it, and now we've got a problem. Undo that just to make sure that that line is our problem. Reload. Okay, that line is our problem. So we're saying color to RGB equals texture whatever times this. That's my problem because texture 2D is a 4 component, and we want to take just the red, green, and blue. So let's do that. Refresh. Cool. So now we're seeing the normal textures, and we are loading those textures in. So this is nice. We've got the things. You can see that the red is pointing to the right, it looks like, and it looks like the green is pointing down. So our texture is loaded, at least. So let's turn off our debug view back to 0. And now let's make sure that we're doing something with these textures somewhere else. So when we're up here, and we've got this TBN matrix to put something into the right place, what we want to put into that place is this texture. So let's load this texture information. We'll say vector for normals texture equals this. Now, the way that these textures are saved in the lab PBR format is it doesn't actually save the red, green, and blue. It saves the red and the green, and then it, because you can kind of configure what would be left, because it's always going to be pointing just at a length of 1. It's a normalized vector. So the blue is just used for another thing. In this case, it's ambient occlusion. And the alpha value, the red, green, blue, A, the alpha is used for height that you can use for POM. So if we're going to use this the way that we want to, we need to get back that blue value, which is the Z. And I'm going to just copy paste that from somewhere. Okay, so here we're loading our texture, and we need to reconstruct the Z value and do something else to it. So let's walk through this real quick. First thing we're going to do is we're going to put it in the right space. So again, it's to save it in a red, green, and blue value, it's in that squished space. So we need to undo what we did on the other one. So we're going to say that the normals, oops, I spelled that wrong. So our normals for the texture dot x and y will equal the normal texture dot xy. This is going to be times 2 dot minus 1 dot. And what that's doing is we're reversing where we did the squish between 0 and 1. Now we want to take it back to going in the other direction. So if this is, let me make a new page for this. It's getting messy. Now here's our 0 and here's our 1 and here's where colors are saved, but we want it also to be able to point in the other direction. So we're going to take this, we're going to double it so that it goes twice as far, and then we're going to move it back 1 so that it covers this range. So that's times 2 minus 1. That's why that is right there. Let me get rid of these little commented ones where I copied stuff because it's just going to look cluttered and you're not going to have those. So we got our bitangent, we made our TBN matrix, we loaded our normal textures, we put the X and Y right, and then here we need to reconstruct the Z. I literally just copied this from the Shader Labs Discord because this is the way you're supposed to do it. Is the normals texture dot Z equals the square root of 1.0 minus dot product of our normals texture xy by itself, it looks like. Because if this is a three-dimensional vector with a length of 1, you can use the two values to get the third value. So we reconstructed our Z value. That's just something you'd probably just have to look up. I did it my own way before that wasn't as accurate, and this is just the way you're supposed to do it. So we've reloaded our texture, we've got our X, Y, and Z put back. The alpha value we're not going to worry about because, like I said, that's a height map, and we are not doing POM this episode. That will be ray tracing. So now we're going to take this normal texture X, Y, Z we've got, and our light dot, instead of comparing to the normal of the face, we're now going to compare it to the normal texture X, Y, Z. Before we do that, let's go down here to our debug view, and let's make another debug view and look at this and just see if we've got it right. So we'll do debug view 3. And this is fun because we're learning. You know, this is what we want to do is we want to learn. And we'll say that our color RGB will be this new value. And again, we'll put it into visible colors on screen. Let's save this. Let's go into our settings and let's make a spot for that. And since we're putting more than a few of these now, let's also go into our shader.properties and let's make sure that this is a slider so that we can kind of more easily move around between the different debug views we've got going on. Let's go back in Minecraft. Let's reload. We've got errors. we're having fun with errors today. Let's see if it tells us anything valuable. Copy the error. We'll go to a new folder. We'll paste it. Invalid, whatever. That doesn't really help us. So where were we? We were in main. We did oh, was I adding stuff to the wrong thing? Okay, so in main we loaded our, oh here we go, this is our problem. We want to load all 4 components of that. I copied that poorly. Let's see if that alone fixes it. It does. So let's go here to our debug views. Let's go to debug view 3. That's got an error. So we know that error has got to be inside of this little spot here. That needs to take our normal texture. It needs to take only the X, Y, and Z values or the RGB values. Those are the same thing. Let's reload. Okay, so now we've got these textures, and if we move our camera, it would hopefully be moving them, but it doesn't seem to be. It seems like they're always just pointing in a certain direction. You know why that is? It's because we did not multiply them by the matrix yet to transform them. So let's take our x, y, and z, and we're going to multiply them by our TBN matrix. We have to do this in the right order. Let's see what that right order is. So we'll say that our normals texture dot xyz equals xyz. Let's see if we'll do this. Try this both ways and see which one works. So if we do that, it should spin it into view or spin it invertedly into view. It's changing when we turn, but is it looking in the right direction? I think we're supposed to do it that way. Let's try it the other way and just see what it looks like different. We probably can't tell without the lighting being applied. Okay, so that's also spinning, but let's see, this should be pointing upwards, and it's no longer pointing upwards, so that's probably the wrong way. It's always good to experiment because it helps solidify what you're trying to learn instead of just doing it. Okay, so green is pointing up. You see here green is pointing up. If we turn the camera, is green still pointing up? It is. And red is still pointing left. So that seems to be the right way to do this. So we've got our normals texture, and it is transforming by our TBN matrix to point towards the tangent, the bitangent, and the normal. So let's use that in the light dot instead of the normals of the face. Let's compare the light position to the normals coming from the texture that are put into the space. And we need to use just the x, y, and z values of that. And let's get into Minecraft. And we're going to turn off our debug view so that we can see if this is actually shading. And is it? I mean, let's go to our thing here, and we're going to say tick rate equals 1000. And that'll make the sun move really fast. Oh, we don't need the equal sign. Tick rate 1000. And let's see if the shading changes as the sun moves. And it looks like it does. When the moon or whatever is over there, it's lit from the left. When it's above, you can see it's lit on top. And as it moves to the right, we should be lit on the side. There we go. We did not load continuity, which for this texture pack to look good and have all the variations, you need to have continuity if you're on Iris. So we don't have any variations on there, and there's bad tiling. That's not the texture pack's fault. That's us not downloading that mod. If we look at the top of this, we should be able to see it there too. Cool. See, the lighting is from one side and then to the other. Nice. Let's put our tick rate back so that we don't give ourselves a seizure. I think the default is 20. Okay, so to review, we made 3D textures work as far as getting the 3D shading from the normal maps with how they get their light from the sun. And we did some different debug views to help us understand normal maps and be able to visualize both like the face, the loaded texture, and then the texture transformed into the view space that we're using. And let's look at our code. What we did is we passed the tangent for the face, just like we were passing the normal. But we pretty much treated it the same. We used the normal matrix times the AT tangent, which was an attribute we got from Minecraft. And then in the fragment shader, we take that tangent and we use it and the normal to get a bitangent, and then we use those to create the TBN matrix. We loaded our normals texture, which we declared here as a sampler 2D, just like the other texture we were also loading. We took our x and y, put them back into a -1 to 1 space. We reconstructed the z value since it's not there. We multiplied our normals from the texture by the TBN matrix we made to make the red and green point towards the tangent, bitangent, and the blue towards the normal. And then we use this new 3D texture normal in our lighting calculation to get our 3D lighting. And I'll draw that one more time real quick just to make sure everybody kind of understands it. if this was our cube in the world and this was our texture, our normal texture, the normal texture, if this was a circle, let's say it was red on this side for things pointing this way, and it was green on the top for things pointing this way. With our TBN matrix, we had the normals from the face that we had coming from the vertex shader was saying which way was up, and the AT tangent that we got from Minecraft was saying what was in one of these directions, and then we used the cross product of those two to get this other direction, and then we took this texture and we multiplied the texture value. So if the texture was pointing towards its top, we said that it would be pointing towards the face's top in this sense, and if the texture was pointing towards its red direction, we would say that it should be moving in this 3D space here of the tangent. So we took these three attributes we had of the face to make that TBN matrix to then translate these texture directions into our view space directions. And that's how we got the normal maps to work. So that's it for today. I hope everybody had a good day and enjoyed making 3D textures in their shader. And I hope you have a better understanding of normal maps and how they work. Talk to you soon.